The quadratic equation 2x squared plus x equals 15 can also be written in standard form. So in standard form, we write it as ax squared plus bx plus c equals 0. So we're going to go 2x squared plus x minus 15 equals 0. Right? So yesterday we were doing it graphically, and we graphed 2x squared plus, or maybe, I don't know if it was this exact one, but one like it, we would have graphed y1 equals 2x squared plus x and y2 equals 15 and found the intersection. Or we could rearrange it into standard form, in which case we want to find the 0. The standard form can sometimes be factored. So if we can factor the standard form, that's really great. It allows us to find the roots, right, or the zeros, or the solutions. Well, there's all different names for what we're doing here. In this case, the factored form of the equation is okay, it's all going to be there on YouTube. Pencil sharpener grinding in the background, me throwing papers on the floor. Okay, you won't actually see the papers falling on the floor, but you will hear the pencil sharpener be grounding. Okay, I need two numbers multiplied to 15, right? So it's 1 and 15, not likely, so it's going to be 3 and 5. Where goes the 3? Where goes the 5? And what signs go with them? So my intuition tells me if I stick a 3 there, and a minus, and a 5 there, then I'll get 2x squared minus 6x plus 5x. Okay, so I got the signs wrong. Got the numbers right. I got 6 and 5, but I want to have minus 5 and x plus 3. Okay, try again. 2x squared plus 6x minus 5x will be plus 1x minus 15. Okay, so anytime you factor, FOIL it out, right? Because the likely, the mistake you're going to make is just in getting those signs incorrect. If you do that, then your roots are wrong, right? The solution is wrong. You have the wrong solution to it. A solution which you could verify graphically, right? That's what we did yesterday, all the graphing stuff. So, many quadratic equations can be solved by factoring. First of all, complete the tables below. Okay, usually if I have a factor, what's the value of x that makes that factor equal to 0? So what value of x makes this 0? 2. Okay, I'm going to pause this and let you fill in the rest, right? Okay, so as if by magic, here's the table all filled in. How do I look at this and come up with this? I just wrote it down. I didn't do any, algebra or anything. I just wrote that down. How do I know it's 5 over 2? Okay, so here's what we do, right? What we're doing is we are solving this equation, right? I want 2x minus 5 to be 0, which means that 2x is equal to 5. So I take this term and I change its sign, right? Because I'm going to basically move it over to the right side. It's going to change from negative to positive or vice versa. And then what do? Divide both sides by 2. Okay, so I look at this, I take this and change its sign, negative 1 over 2. I look at this, change its sign, positive 1 over 3. I look at this, change its sign, negative 3 over 5. I look at this, it's after 0. Okay. Make sense? It's a quick way. Okay, if you don't want to do the quick way, do it the slow way. Just get 5 over 2. I don't care how you get 5 over 2, just make sure you get 5 over 2, right? If you're doing the question and you're solving by factoring, remember you can always check by graphing. All you have to do is graph it and find the zeros off of your graph. That'll verify. Do not do any verifications while you're writing the test, right? Wait until when you're done the test, if you finish, then you can go back and do some verifying. Okay, if you verify while you're writing, you just won't finish. Next, what values will make each of the following expressions equal to 0? So this is basically the factored form of a quadratic, right? This is the factored form of x squared minus 7x plus 10. Okay, so if we were given x squared minus 7x plus 10, we would write it as a factored form, and then we would find the values of x that make this expression 0. So what are they for this guy? 2, and 5. Okay, what are they for this guy? These two. -3 and -6. This one. 1/2, -3. Okay, fill in the rest. 0 and 2, -1/2 and 2, -3/5 and 1/3, 0 and 5/2, and 0 and -1/3. Okay, we don't put parentheses around them because they are not points, right? They are values of x, right? So this comma this. It's just a list of numbers, right? It's this number and this number. Okay, agree, disagree? Agree? Good. Just either means we're both wrong. And write the solutions to each of the following equations. Okay, so same deal, right? Now we just say x equals 2 or 5, right? So that's the idea, right? We're going to get an equation in this form because this unit, right? Last year was quadratic functions. Quadratic functions, the idea behind that unit was, hey, here's a graph of a quadratic. We want to find the vertex, right? Because the vertex is the max or min point, and that's where we can get the maximum profit or the minimum maximum area or the minimum cost or something like that. We're looking for a maximum or minimum with quadratic functions. So we're looking at the whole graph and trying to find the vertex, basically. Right? So how do we do that? We do that through partial factoring or factoring, right? Axis of symmetry, et cetera, et cetera. This unit is quadratic equations. In quadratic equations, we are looking for the value or values of x that make the equation equal to 0. Okay, so yesterday we did graphing, and we found the zeros off the graph, right? Or we did like 2x squared plus x equals 15, and we graphed y1, y2, and found the x coordinates of the points of intersection. And today we're doing this, where we are factoring and then finding the values of x that make it 0. That's just the same chart that's above, right? It's just right, so we're just kind of stepping up to it, right? We're just saying, hey, here's a factor, what value of x makes it 0? Here's a couple of factors, what value of x makes the expression 0? And then look, here's an equation where it is equal to 0, what values of x make this 0? So if a quadratic equation is in the factored form, ax minus b and cx minus d equals 0, where a, b, c, and d are integers, then the solutions to the equation are, so what's the solution to this guy? Take the negative b, b over a, right? Take the b, change the sign, b over a, and what's the other one? D over c. Now, notice these are given with brace brackets, right? Brace brackets say that this is a set of numbers. It's not an ordered pair, it's a set of numbers. Okay, so that's just a more formal way of saying it here. I'm okay with you just writing them down here, right? X equals 0 and 2. Just don't put brackets around it because you'll make it an ordered pair, and that could be like a vertex or something, but it's not an ordered pair. To solve a quadratic equation by factoring, if necessary, simplify both sides of the equation. Okay, so we might have an expression, right? 2x bracket x minus 3 equals 4x bracket x plus 2. So we need to simplify the sides. We need to collect all the terms on one side, right? You're going to have a squared term. You must have a squared term. Otherwise, it's not a quadratic. Okay? You got to have a squared. You may have an x term. You may have a constant. You may not. Right? You don't need those, but you must have a squared term. Okay, simplify both sides. Rearrange the equation so one side is equal to 0. Factor the non-zero side. You can't do much with the side that's 0. The solution is the values for x that make each factor equal to 0. The answers to quadratic equations are called, I don't know what they want here. There's various different names. I'm going to go with answers to quadratic equations are called roots. I'm going to go with roots. The roots of an equation have the same, well, you should check the actual answers. I reserve the right to change these, okay? I want to look at, because there's different names for things. Roots of an equation have the same value as the blank of the corresponding graph. So the graph has x-intercepts. And the blank of the corresponding function. I was going to think of this, right? There's like three names, so it's not, you don't really have to know them, right? You just have to understand sort of the concept. If I have a graph has x-intercepts, right? So here's the function, right? When we talk about the function, it's y equals, and we got the whole, the function, which is the entire graph. And last unit we were looking for the vertex. That graph does have x-intercepts. Those x-intercepts are the solution to the quadratic. So the graph, roots of an equation, same value as and the blank of the corresponding function. What are they? The zeros of the function. That's the word. Zeros. So zeros of the function simply means the values of x that you plug into the function, they give you a y value of 0. Okay? So the zeros of the function, the x-intercepts of the graph, and the roots of the equation. All right. Now, you don't have to know that, right? You just have to be able to solve the thing, right? So solve each of the following equations by factoring. If we say it factors, okay? Now, when you go to write the test on this unit, you're going to have other ways to solve than factoring. So we'll just say, we might say algebraically determine. You should always check and see, does this factor? Because that's the easiest way, right? Factoring, very easy, simple solution. If you can't factor it, that doesn't mean it doesn't factor. It just means at the moment you can't factor it. You will have other ways to do it. If we say solve by factoring, you must factor, and it does factor. Okay? So we're not pulling a fast one on and say solve by factor. It doesn't factor, right? Like, they're going to spend like 20 minutes trying to figure this one out. Okay? So if you are in the process of spending 20 minutes trying to figure it out, go on, right? And I'll tell you ways that you can find the factors, right? So if you can't factor something, you can kind of work your way around it. You can use your calculator. If you use your calculator, you can find the roots, and if you find the roots, you can figure out the factors from the roots, right? If you say, hey, x is a half, then that means the factor is this. Okay, but factoring is the easiest way, right? So if you're having problems with factoring, if your factoring skills need a little brushing up, go to Khan Academy and watch some videos on factoring. Go on YouTube, there's a lot of videos on factoring. Okay, so find something that speaks to you. I don't really care what method you use, right? You say, can I use this method to factor? Because the method I use is called guess and check, which means you don't even see any work. So it's not like, can you show me what work? No, there is no work. Right? I put a 2 and a 2, and I put the 3 with the 2 because that gives me a 6 and the 5, and I want a 6 and a 5 because I can get a 1 out of that. And whoops, I got the signs wrong. So, that's how I factor. Okay? I don't care how you factor, just you need to be able to factor. Anyways, let's do it. So we're going to move the x squared over, right? So that's going to give me positive 1x squared. I'm going to have to add x to both sides. So this will be plus 2x minus 3 is equal to 0. What I'm going to aim to do when I rearrange is to get a positive x squared value, right? I don't want to move the 3x squared over, subtract 3x squared from both sides, get negative x squared, right? I can't factor that easily. So I'm never going to attempt to factor something that has a negative x squared. I'm always going to ensure that it's a positive x squared. Okay, well, put down 2 brackets. That's a minus sign. I know there's a plus and a minus here. I know the only way I get x squared is if each term leads off with an x. And I know that the final 2 numbers are a 1 and a 3. And I just got to figure out which one's a 1 and which one's a 3. Now the larger term here is positive, so that tells me the bigger number will be the 3. And I'm going to check, because the method I use is called guess and check. And whatever method you use, you can call it whatever, but add the words and check to the end of it. Okay? You can factor by decomposition and then check. You can factor by over the rainbow and then check.
How did you know it was 3?
Magic. So you look at the last term as 3, right?
Yes.
I need 2 numbers that multiply to 3. So it's 1 and 3. So the numbers aren't in doubt. Now I just got to figure out which one's which.
Okay.
I know 1 is positive and 1 is negative because that's a negative sign. Right? The only way I'm getting -3 is -1 times +3 or -3 times +1. I now look at the middle sign and I say, well, if the bigger term is positive, then the bigger number must be positive.
Okay.
Right? So now I'm going to check. X squared minus 1 plus 3 is plus 2 minus 3. Okay? If you reverse the signs, the only other possible factorization you could come up with that makes any sense would be minus 3 and plus 1. Right? You can't put like a 2 there and a 7 there, right? It's going to be 14. So it's got to be a 1 and a 3. Okay? So the only possible thing you could do is get the signs. You can put both pluses, in which case you're going to go plus 1 plus 3 is plus 4, and you'll go, okay, that doesn't work. And if I have both pluses, I won't get a minus here, right? Okay, so what are my answers? So x is equal to, we'll use the set here. So negative 3 and positive 1. We call that the solution set. Okay, and we use set notation. Get used to it, because 30-2 is a unit on sets. So you're going to see set notation. You're going to see those brace brackets. And you're going to spend a week or two looking at the properties of sets of things, sets of numbers, sets of whatever. Okay, next one. We have to expand this. So write down the next line. And remarks could say, go. Just do the next line. You don't have to go. If you want to go further, you can keep going, right? So the method is we're going to expand the right-hand side. We're going to collect all of the terms on the left side. And have the right side equal to 0. We're going to factor the left side. We're going to find the values of x that make the factor 0.
Why did you change it to negative 3?
Look back at the last page. What did we just spend the entire last page doing? Yeah, right? Because the idea is, I want to know what value of x makes this 0. So negative 3 makes this 0. Right? Positive 1 makes this 0. If this is 0, it'll be 0 times some number. And I don't even care what the number is, because there's this thing in math, it's called the zero product property. And it basically says, if you have two things that multiply together and you end up with a 0, then one of those two things is a 0. Or they're both zeros, right? So it basically says if A times B is equal to 0, then either A is 0 or B is 0 or A and B are both 0. Okay. And that's what we use. We use that a lot. That's the whole basis of this factoring. Right? Factors. What are factors? Factors are just things that multiply together, right? That's why we're factoring this. Take a trinomial and say, write it as the product of two things. Why write it as a product? Because if I set each of the individual products to 0, I get my solutions. And that's why we're factoring. Okay, so what do we got? 2x squared plus 5x. So this side doesn't change. And here I got x squared plus 2x plus 10. Okay, so we need to expand both sides, right? Then we need to collect our terms together. I have a larger x squared on the left, so I'm going to move everything left. So I'm going to subtract. So 2x squared minus x squared is x squared. 5x minus 2x would be plus 3x. Minus 10 equals 0. Okay, now I want you to factor that. You need two numbers that multiply to 10 and differ by 3. Okay. Now the reason they differ by 3 is because we know that one of the factors is positive and one is negative, right? So the difference between them, because we're going to end up with a negative factor and a positive factor, and the difference between them is going to be 3. And the bigger number is going to be positive. Okay? So I think two numbers multiplied by 10 are 1 and 10, but if I use 1 and 10, I'm not going to get a 3 out of them, right? I can get 10 and 1 is 11 or 9. So the way I think about it is, okay, two numbers multiply to 10 and differ by 3. 1 and 10 multiply to 10, but they differ by 9, or they add to 11. So two other numbers multiply 10. 5 and 2, right? 5 minus 2 is 3, 5 plus 2 is 7. So if I'm looking for a 7 in here, I'm going to use 5 and 2. If that's a plus 7, then it's going to be, looking for 3 here with the 5 and the 2, they differ by, if that was a plus 10, that would be a plus 7 if they were 5 and 2, right? It'd be plus 5 plus 2. Okay, guess check. X squared plus 5x minus 2x is plus 3x minus 10. Now, what's the solution set? Okay. In order from left to right, the way I wrote the factors, 2 and negative 5. Do I care what order you put stuff in? No. Right. So whether you write x minus 2, x plus 5, or x plus 5, x minus 2, it's good. If you write x plus 2, x minus 5, it's wrong. And then your answers are wrong. And how do you know they're wrong? You can actually graph that, right? Do a left side, right side. y1 equals 2x squared plus 5x, y2 equals x bracket x plus 2 plus 10. Just graph it exactly as you see it. And what you should say is this, right here. Let's do this. So here, we're going to check this. So I am going to turn this on. I'm going to go to y equals. I'm going to do 2x squared plus 5x. 2x squared plus 5x. And the other one I'm going to do x bracket x plus 2. I'm just entering it exactly as I see it, right? I don't want this, because what if I got this wrong? I want this, plus 10. When I hit graph, these lines should intersect when x is 2 and negative 5, right? So when I hit graph, I should be able to look at negative 5, count over the ticks, right? And it's just going to be a standard window, right? Zoom 6, standard window. So 1, 2, 3, 4, 5, so they should intersect here. So now you can see this graph is way up here, right? And they should 1, 2, they should intersect here. Okay, well, I can't quite see that, so I need to set the window. To help me set the window, I can go second function graph, go into the table, because I want to say, fine, look, when I've got negative 5, what's the x value? It's like 25, right? So I got to go up to 25. And when I've got positive 2, what's the x value? 18. So my window here, let's take, or sorry, the y value, let's go 0 to 30 by 5s. Doesn't matter. Okay, one graph, second graph, 1, 2, looks like 2. 1, 2, 3, 4, 5, kind of looks like it, for sure. Second calc, intersect. Move, I want to move to x is negative 5, so moving along here, right? About negative 5, close enough. Negative 5, second calc, intersect. Move, I want to move till x is positive 2, right? Because I know what the answers are. At least I think I know what the answers are. Cut it out. I think I know what the answers are. Stop. Close enough. 1, 2, 3. Positive 2, right? There. Verification. Do not do this on a test until you're done. You can go back later, you can verify, right? So you're handing that thing in early. You're basically telling me, yeah, I went back and I verified all of my answers, right? So I know that they're correct. You hand it early, you get these wrong, it's like, whoa, come on. I mean, you should have known this was wrong and done something about it. Don't just hand it, hand it in half an hour early. Okay. So you can check. X squared minus 16 equals 0, special products. This is a difference of squares, right? How does it factor? Okay, difference of squares, factors like this. If you need a review on difference of squares, go to YouTube, type in difference of squares. You'll find 100 videos. You might even find something neat. If you find something neat, show me. So, hey, I found this really great way of factoring, right? I wouldn't mind knowing. Okay. You don't have to share it with me, though. It can be your little secret. I found this great way of factoring. I'm not going to tell anybody. Keep it all to myself. Because I don't care, right? I don't care how you factor. What I care is you get the expression, you factor it somehow, right? You'd be doing it on scrap paper. You'd be just doing it. You then set each factor to 0, you get the solution. Okay? And then if you have time at the end, you go back and you check. Is this right? Yeah, I graphed it. Looks good. Okay. Any questions on this stuff? On these guys, right? So this one requires rearranging. Right? Actually got to circle it because, I say on the video, this one requires, and somebody's watching the video going, what? Which one? Okay. This one requires us to expand the right-hand side and then to rearrange, right, to collect terms on one side. And this one, that's just a straight, it's what we call special product. Okay, a few more. What's the first thing I should do with 4x squared minus 36? What's the first step always in factoring? Take the common factor. What's common between 4 and 36? 4. So we can common factor and go 4x squared minus 9 equals 0. So 4 is still one of the factors. X squared minus 9, special product, difference of squares. How does it factor? Not magic. Where did the 3 come from? What is 3? Square root of 9, right? Same as x squared minus 16. What's the 4? It's the square root, right? So it's x plus the square root of, actually, really, it's the square root of the first term plus the square root of the second term, and it's the square root of the first term minus. You know why, right? You know why. Take a minute. If I expand this out, right, I get x squared minus 3x plus 3x. What's minus 3x plus 3x? 0x, right? So the x terms cancel. And then you've got positive 3 times negative 3 is minus 9. That's how a difference of squares works, right? You got these same terms, but with opposite signs, so you're going to cancel out. Remember FOIL, first, so the first is x squared. Outer plus inner are going to be the same with opposite signs, right? Minus 3x plus 3x. They're gone. And then you've got last, minus 9. What's x? Here's a fancy way we can write it. Okay, we could say plus or minus 3, right? Which says positive 3 or negative 3. Just a fancy way of saying it. You can write that. You can write negative 3 comma 3. You can write 3 comma negative 3, right? All are acceptable. And one reason that I might show you lots of different ways of showing the solution is on a multiple choice, you don't know what you're going to see. Right? Maybe you see x equals 3 comma negative 3. Maybe you see x equals plus or minus 3. Okay? So you need to be able to look at it and say, oh yeah, that's the same. Okay, what do I do here? First step, right, which is common factor. And what's the answer? This one? What's x? What value of x makes that 0? Just 0, right? It's too easy. So when you see an x by itself, right, when will that happen? That'll happen when you've got basically only 2 terms. So I got 2 terms, and it's not a difference of squares. And the 2 terms, one's an x squared and one's an x, so that I can factor out an x, and I end up with an x as a factor, right? So that's 0, and this guy is negative 1/3. Okay, take a moment, rearrange the next equation, right? You gotta do some rearranging. We gotta get the right-hand side equal. Actually, you know what? I'm gonna go for the left side equals 0, because I want to have a positive 6x squared, right? I want you to have a positive experience in factoring, which means you need a positive x squared value. Do not try and factor in negative x squared. It will be a negative experience. Right? Because basically, if you're factoring a negative x squared, you're going to need a negative factor and a positive factor on the x, and we just don't do that. Right? It's not that you can't do that, but you don't do that. Remember the NHL rap, only this time imagine him saying, you don't do that. So I'm going to add 6x squared to both sides. I'm going to subtract 26x. And I'm going to leave the 12 the same. Right? So I'm moving the left side over to the right side. Okay. Why? Because I want a positive 6x squared. And now I'm just going to reverse the sides. X. Okay, so I added 6x squared to the right side, became 6x squared. I subtracted 26x from both sides. Why? It's a plus 26. If I move it over to the other side, it changes sign, right? So it's minus 26. So I get negative x minus 26x is minus 27x. Okay, plus cost. Is there a common factor between 6, 27, and 12? 3, right? If you didn't take it out, it's not like it's a fatal error. You're still going to get, it's just, you're going to make your factorization a lot more difficult, right? Because you think about what numbers multiply to 6, 1 and 6, right? So I either have, and 2 and 3, I either have 6x and 1x or 2x and 3x. What multiplies to 12 at the end? 1 and 12, 2 and 6, 3 and 4. I have an awful lot of numbers that I've got to play with to get the factorization. If I take the 3 out, 2x squared minus 9x plus 4, then I know that one of these factors is a 2x and the other one's an x, and I got to play with two numbers at the back end and multiply to 4. That's a plus 4, so I know they're both the same sign, right? The only way you get plus 4 is to have a plus and a plus, or a minus and a minus, and in this case it's got to be minus, right? Because that middle term is minus. So if I put two pluses in there, I'll just end up with pluses. Outer and inner will be positive, and they need to be negative. So let's go with a minus 4 here and a minus 1 here. So I get 2x squared minus 8x minus 1x is minus 9x plus 4. Good. So it's factored properly. Okay? Now if you look at that going, that's magic. Sure. No, that's experience, right? And, you know, but you're not going to have to factor things a whole lot more difficult than that. And you won't be doing like 20 factorings on the test. Okay? So, you know, if you have figured out that, hey, factoring is just not my strong suit, you can leave those questions till later in the test, right? You can say, okay, I can come back later and I'll do this factoring thing. Also, okay, do you want to know how to get the factors if you don't know how to factor this? Okay, here, I'm going to show you. I'll even put it on video. Here's how to find the factors when you don't know how to find the factors. We can do this two ways, one of which is we can assume you've got this correct. Should we do that or should we just go back up here? Maybe we should go back up there. It's like, I don't even know if I got that correct, okay? So, watch. You might use this. If you're going to use this on a test, you do this last, okay? You leave this question and you say, I'm going to leave it because I know it's going to take me a while, right? And I might not remember exactly how to do it. And I don't want to spend 20 minutes in the middle of the test doing this and then find out I didn't do the last page or something, okay? So you look at a question like that and you go, whoa, not happening now, okay? You want to do a test? Probably didn't play. You go through a test 3 times. Well, no, okay. I go through a test 3 times. So you can adopt this strategy or not if you like. I do 3 passes through a test. My first time through, I just read the first question. I read a question and I say, do I know how to do that? Yeah. How long is it going to take me? 10 seconds. Then I'm going to do it, right? Like it's just a knowledge question. It says the vertex and the A and the C. I don't have to do anything. I just need to think about it for a second or 2 or 30 seconds. I do that question. Those I call the easy questions, right? They're knowledge-based, or it requires a very small calculation, right? I got to put one number, I got to put 3 in here and 5 in here, whatever. Right? Easy to do. That's stage 1 questions, the easy questions. Stage 2 questions, they're the ones you know how to do, but I know this is going to take me a while, right? Like, okay, I got to do partial factoring. I know how to partial factor. I also know it's going to take me like 5 minutes to do this question. So I'm not going to do it right now, but I will come back to it, right? I'm going to have lots of time. I'll come back to it. Type 3 questions are, I was away that day, or maybe I wasn't away that day, but I've never seen anything like this in my life. I have no idea what to do. That's type 3 question, right? It's like, I have not got a clue. I don't even know what I should be doing. I don't know how to start this. You do 2 things with type 3 questions. You either never do it, because you're not likely to get much in the way of marks anyways, or you've gone through, you've done all the type 1s, you've gone through, you've done the type 2s, right? You knew they would take longer, but you know how to do them, so you're done them. And now you got a half hour left, and you got like 3 questions to look at. And you say, okay, I can spend like 10 minutes on each of these guys, right? I have time. And the other thing that happens is sometimes by doing a question later on in the test, it sort of twigs something, and you go, oh yeah, that type of question I wasn't sure about, I remember how to do that now, right? Because it's like this question that's like on the last page. Okay? So, type 1, go in, get your marks, right? What's your job on a test? Is it to do absolutely every question? I gotta write something down for every question? By the way, don't leave multiple choice blank. You do have to write something down for every multiple choice question. But your job on a test is not to do every question. What's it to do? What's the objective? Get marks. That's what tests are all about, right? Tests are about marks. Get marks. What kind of marks do you want? You want to get the highest mark that you can on the test. Sometimes leaving a question blank will get you more marks on the test than doing that question. Right? And what I mean by that is you got a 3-mark question that you just spent 15 minutes on in the middle of the test. And now you're rushing to do the last 3 questions on the test, which if you'd have done them earlier, you wouldn't have had to rush, right? Like you know how to do them, but they're just going to take time. And now you don't have time. And so you lose marks. because you tried to get marks for a question that, wasn't working. So go through the test 3 times, right? First time, pick out the easy. I call it cherry picking, right? It's just do the easy stuff. Second type of question, you'll recognize them. I know how to do that, but it's going to take me like 5 or 10 minutes to do this. That's fine, because later on you'll have time to do it. And the third type of question, I'll come back to it later. All right, so let's look at this. How do we do this? Go y equals. I'm going to put in negative 6. You might want to follow along on your calculator. Negative 6x squared plus 26x. I can actually edit this to insert 6. Okay? And I'm going to clear this because I'm going to go 12 minus x. We're going to go 12x and really mess things up. Okay? So, left side y1, right side y2, right? What are we looking for? We're looking for the solutions. What are the solutions? We never stated them. What are the solutions? What's this solution? 1/2. What's the solution? 4. Okay, we're going back here. This, for us, is a type 3 question, right? Don't know how to do that, man. Like, I'm looking at that, I don't even know what I should be doing on that. Okay, but here's what I can do, right? I can graph, I know I have to solve it, I can graph. y1 is the left side, y2 is the right side. Okay? So if I do that, I should be able to find the solutions. I'm just going to go zoom standard. Now, it's going to graph 2 things, right? So there's the 2 things, right? So here's one, and here's the other. Can't quite see the solutions, right? So we're going to pop up a bit. So let's see. I'm going to go from -1, 0, 1, 2, 3, 4, 5. And I go from like -1 to 5 on my x's. And I'm going to go from 0 to something bigger. Okay? Just so that I'm kind of zooming in a bit, right? So -1 to 5 on my x's. And 0 to, let's try 20. I don't know if 20 is good. Maybe it is, maybe it isn't. Is it good? Does that look good? I haven't looked at it yet. Looks good? Looks fine. Okay, don't need the vertex, right? Why not? We're not looking, right? This is not the first unit. So the problem's going to come on the QM exam, right? The QM exam is going to be like, all right, am I finding the vertex or 0, right? So am I looking at an equation? An equation will be equals 0. A function is y equals, right? So unit 1, quadratic function in the form y equals whatever, right? Factored form, standard form, whatever. So y equals 2x squared plus 7x plus 12. Unit 2, 2x squared plus 7x plus 12 equals 0, right? I'm solving an equation. I'm finding the values of x and make it 0. Okay? When you get to the cube, you have equations, y equals, right? Functions, y equals, that's the whole graph. Usually we're looking for the vertex or the axis of symmetry, various other points. This is equation. Okay, I need to find this x value, right? Second calc value. Second calc intersect. Where am I? If you don't know where you are, there, that's 2, right? And so 2 and 28, that's off my screen. I want to come down a bit. Okay, I'm getting close. Close enough. 1, 2, 3. Okay, I have x equals 0, so forget this is here, right? We're doing this, right? We got x equals 0.5, okay? Because we're going to work this backwards, right? Okay, and then we've got second calc intersect. And I'm going to move down to the straight line, so I could just move along the straight line, because it's easier. And I just keep tapping. You don't have to do, well, you sort of have to do this. Okay, and what do I got? 4. So 0.5 and 4. Okay. See, so right now we're here, right? We're on this line. We got to go backwards. Here's how we go backwards, okay? Watch. Okay, I know that x is 0.5. Let's do this over here. So I know that x is equal to 1/2, right? Because we're going to write it as a fraction. So if you had 0.3333, you'd write x equals 1/3, right? So just write it as a fraction. And now you say, this is this, right? That's this. Where did this come from? Well, it meant that I solved this expression, so I'm going to work backwards, right? That means that 2x is equal to 1. Got to get rid of the fraction, which means that 2x minus 1 is equal to 0. I just got my first factor, right? And I haven't factored. right? But I have figured out what the first factor was. There's a factor. I know that x equals 4, which means that x minus 4 is equal to 0. There's my second factor. So I now have two factors, right? 2x minus 1 and x minus 4. Yeah? Okay? So you can now, from this line, right, from this gives you this, right? You got that from the calculator. You just start at the bottom of the page and you write x equals 1/2 and 4. You now go back here and you write 2x minus 1 and x minus 4, because I got my two factors. Now you look at it, you kind of want to do this, right? Like you need this. And you see the 6x squared, and you say x me, so there's a 3 in front, right? Because this gives me 2x squared, so that's going to give me the 6x squared. And you work your way into the middle, right? Or you just go back up here to the top, and you get down to here, and you get to here, and then that's your factor. You multiply this out. So, okay, how do you get this line? You go 2x squared minus 8x minus 1x is minus 9x plus 4. So now you can write down 2x squared minus, so forget the 3 for now. You got 2x squared minus 9x plus 4, and now you kind of work your way down and say, but I need a 6. So, okay, I better put a 3 in front here. Okay, you're done. Okay? So if you know the factor, or can get it off the calculator, sorry, if you know the root, right? I've got the root, I've got the 0, I know what x is, it's 1/2. What's the corresponding factor? So I set x equal to 1/2, and I reverse it out until I end up with something equals 0. That's the factor. I got x equals 4, which means x minus 4 equals 0. That's the factor. Okay? You might have to practice this a bit. I wouldn't practice it a whole lot. Remember, this is the fallback, right? It's the, like, okay, I got no clue. What can I do? That's what you can do. Applications. A ball is thrown up in the air and allowed to fall to the ground. So that's called projectile motion, right? Projectile motion is a quadratic. We know that, right? We spent that in last unit, right? We hit golf balls and we drop balls and stuff like that. This ball is thrown up in the air, fall to the ground. Height of the ball can be described by the equation. You saw this was on the test even, right? Pretty similar. If the ball was initially thrown up in the air from a height of 75 meters and a speed of 10 meters per second, then write an equation for the height of a ball. So height as a function of time is negative 5t squared. V0 is the initial velocity, that's 10. So we go plus 10t. And h0 is the initial height, so plus 75. Okay? So all we're doing is kind of matching up what's V0 and what's h, right? And so height, 75, and initial speed, 10. Graph the function using an appropriate window and sketch the graph on the axes below. Label the axes. Okay, so we know a couple of things, right? We know that time is going to have to be positive, right? I mean, at time 0, and if you put a 0, just say, what happens if I put a 0 in for time, right? That's 0 and that's 0, I end up with 75. What's that? Oh, my initial height, okay, right? Because this is height as a function of time. So the height at time 0 is 75, right? The height at time 0 is the h-intercept, right? That's question 30-2. Congratulations, you've done a 30-2 question, right? They'll ask that, right? Seriously, diploma question. You know, here's the thing, and in order to find the initial height of the ball or something, they won't give you this, but they'll give you this. In order to find the initial height of the ball, you need to find the h-intercept, find the t-intercept, find the time, find the height when t equals whatever, and give you, there's a couple of crap answers, right? So there's two semi-serious answers. It could be this or this, and there's a couple of, really? Why would they do that? Okay, because somebody's going to pick them. That's why. I mean, somebody's always going to pick them. Okay, so we got to graph this, right? Negative 5t squared. Okay, let's move this over. Y'all are following along on your calculators, right? I know this. Okay, negative 5x, because we don't have a t squared, plus 10x plus 75. Okay. Window. I'm going to start at time 0. I'm going to go for, I don't know. So I'm going to say 10 seconds, right? I don't think it's 10, but I'm going to go for 10. Why min? Well, we threw the ball, it started going up, right? So it's going higher. So I'm going to go 0, because that's when it hits the ground. And let's go up to 100 by 10s. Okay, I have no special knowledge, right? This is the first time I've ever seen this question. So I have no special knowledge of this. I'm just pulling some numbers, and then we're going to see what it looks like. That's it. Decent, but 1, 2, 3, 4, 5. Looks like it hits the ground in 5 seconds. So you know what? Let's take the window. Let's take this to 6, just so I can go a little past. I don't mind the 100. I think the 100 is good. Okay, so I think that's a pretty good window. So when we set the window here, right, so we say, okay, I went 0 to 6 by 1, and I went 0 to 100 by 10s. So that's the window I'm using. Okay, here's the graph I have. Whoops. So where's the graph? I want to sketch that graph on here. So it kind of starts at 75 and does that, right? There. So this is height, and this is time. Actually, I should probably drag that out a bit more if I'm going to say, okay, let's just say, there's 6. 0, right, there's 100, and that's 75. Okay, so we know that, right, which I guess makes that like 50 and 25. Okay, so last unit we would be interested in, hey, what was the maximum height of the ball and when did it happen, right? Maximum. This opens down, we know it has a negative A value, which we can actually see. Okay, what are we doing here? Graphically determine when the ball hits the ground, right? What are we interested in? The x-intercept. When does the ball hit the ground? Okay, 2 ways to do that, right? You could do second calc, and I want this 0. I never liked this way, but I'll do it anyways. Clear that out. So I need left bound. Cut it out. There's my left bound, need right bound. This has to go negative. That's all that has to happen here, right? Y value has to go negative. Good enough. And then just get close to 0. Good enough. 5. Okay, graphically drawing the ball hits the ground. 5 seconds. 5. Okay, when is time, right? Time is measured in seconds in this case. So 5 seconds. Don't just write 5. 5 seconds. Algebraically determine when the ball hits the ground. Wow, left a lot of space for us there, didn't they? So we have negative 5t squared plus 10t plus 75 equals 0. Good, I got this down. This is the, I need to go to the bathroom. So I know it's really a timeout, but until I get the glowing sticks. Okay, so we can take a negative 5 out as a factor, right? So I can take a negative 5 as a factor. So what does that leave me with? T squared minus 2t, right? Because I'm basically dividing positive 10 by negative 5, right? And then I'm going to divide 75 by negative 5. Okay, so I factored out the negative 5. One thing we can actually do here is just make the negative 5 disappear. I'm not going to, I'm going to leave it there, but it could just disappear, right? Because you could say, look, since the right-hand side is equal to 0, I'm going to divide both sides by negative 5, right? And then that just gives me this. But I'll write it in factored form. So negative 5 bracket t, 0, let's not waste time, minus 5 plus 3. Okay, so 2 numbers. I don't care how you factor, just be able to do this and check it. T squared, so I got plus 3t minus 5t is minus 2t minus 15. Good. Okay, so what's t? T is equal to 5, or t is equal to negative 3. Okay, and you can cross that off, right? Because in the context of the problem, a negative time doesn't make any sense. If we went to the graph, and set my window, and said negative 5 for the x's, then we'd see, oh, here's the other one, right? So you could say something like, well, 3 seconds ago this ball could have been launched from the ground, right? Because it was at a height of 0. Okay, but that's not what happened, right? We were at 70, and then 3 seconds later it reached 75 meters. Okay, and then it fell to the ground, it kept going up for a bit, hit some maximum height at some time, and that could be on the cube, right? This question, right? Like find the maximum height, and then find the intercepts. We already did that for the last unit too, but what are the intercepts? That's this unit, right? Solving. And we'd ask you to solve algebraically determined. Okay. Questions? The height of a parabolic archway is given by the equation. H of W is negative 0.65 W squared plus 5W, where H is the height in feet and W is the width of the arch in feet. A diagram of the arch is shown below. Determine the height of the arch at a distance 1 foot from the end. Now, I don't know what that means. I guess it's 1 foot from here or one. It doesn't matter, right? Because it's symmetrical. Yeah. So 1 foot this way and 1 foot this way, they'll be the same height. Okay. Yeah. It's the height. It's the height 1 foot from the end. This is 1 foot.
Oh,
Okay. This is width. This is 1. So I don't even know what this width is here, so let's go with 1, right? So what are we going to do? We're going to substitute a 1 in to the equation. We want h of 1, negative 0.625 W squared. So, okay, let's start with the formula. Plus 5W. We want the height when you're 1 foot in, right? So the width will be 1. So h of 1 is negative 0.625 times 1 squared plus 5 times 1, which is really just 5 minus 0.625. So what's that? 0.37, 4.375? Check it on a calculator. Okay, check that. I don't want this being some wrong answer. Okay, yeah, that's right. Okay. Negative 0.625 x squared plus 5x. Okay, because use your calculator to determine maximum height of the arch. Okay, we want to set a window. I'm just going to use what I got. Let's just take a look and see. Okay, it's not that high. Right? What was that scale? So again, we can start at 0. We got to go 1, 2, 3, 4. It kind of looks like it's peaking around 4, so I'm going to go up to 10. So let's go 0 to 10, and then let's go about one of these ticks high. What was that? So 0 to 10 by 1s, and 0. Well, we don't need to go to 100, so I'm going to say, let's say 20 by 2s. All right, that's pretty good. Huh? Right? You need to be able to see the whole thing, right? So yeah, adjusting a window isn't all that difficult, right? And again, if you need to see numbers, you can go into the table and play with numbers to sort of see how high does it go. You know, I'm betting it's at 410, right? Actually, I know it's at 410 because if I move 1 unit from 4, I'm at 9.375, and I go 1 unit this way. So 4 has to be the vertex because these two guys are at the same vertical height when they are 1 unit from the vertex. So I know it's 4, but let's actually do it. So second calc, maximum, number 4, right? Left bound. Cut it out. Okay, left bound, right bound. All right, one more time. Second calc. Oh, I didn't intersect, nice. Second calc, maximum, 4. Left bound, go to the left of the maximum, right? Hit enter. See, no, it shows you that mark there to show that you're looking from there. Enter. Whoa, stop. How does it get stuck? It's like I have no idea. It keeps going and going. All right, so it's 410, right? Use the max height, the maximum height. It's going crazy. Okay, maximum height of the arch is 10 feet. You can find that from this crazy calculator. It's still going. So y value of negative 6. Okay, hold on. Wait. Okay, die. A crate. I've never seen that. That's interesting. Didn't know you could lock a key on. If I knew how to unlock it, that would be a useful skill, locking, unlocking. A crate that is 7.5 feet high must be moved through the archway. Algebraically determine the maximum width of the crate if it is to fit through the archway. Okay, so what do we know, right? We know that this is the point 410. We know that this is 4, right? So I know that what I want to figure out is this. Actually, that's W1. Okay, so what we want to figure out is when is the first width where the height is 7.5. Okay, use your calculator. Mine's broken. Okay, so hopefully at least one of you has graphed this already. So what are you going to do? So you have to enter what? Y2 equals 7.5, and you need to find the intersection of Y1 and Y2. So what's W1? Come on, how long does this take? 2. Exactly 2? Cool. Okay, what's this one then? You don't need a calculator. This is the middle, it's 4. This is 2. That's 6, right? By symmetry, right? We know that. Okay, because we know where the axis of symmetry is. So how wide? From 2 to 6 is 4 feet wide. Algebraically, oh, it said algebraically. Damn it. So we weren't supposed to use the calculator. Oh, see, I didn't even need the calculator. Okay, what did we need then? Okay, now we know the answer, right? So we can work it out. So this might be a strategy you do on the test too. Say, hey, I can work this out pretty quickly algebraically, right? So at least I know what my answer should be, right? I should be getting 2. Okay, so we have an expression, right? Negative 0.625 w squared. So what is it? H equals plus 5w. Okay, I want h to be 7.5. Right? I want h to be 7.5. We're going to do this algebraically. So we're going to move the right side over to the left side to give me a positive w squared, etc., right? Okay, so 0.625 w squared minus 5w, because that comes over, plus 7.5 equals 0. We're going to factor 0.0625 out of this, right? Because I'm willing to bet that 5 divided, what's 5 divided by 0.625? Where's 0.625? It's like 13 or something, right? 8. Okay, well, it's like 13. 8. It would have been impressive if I'd actually got it right. What is 7.5 divided by 0.625? I should have known that. 0.625 is 5/8. 12. Nice. Nice numbers. Okay, so I look at that. I want to factor it. I do not want to look for two numbers that multiply to 0.625, right? That's just math. So I say, hey, let's divide a 0.625 out. Oh, look, these are nice numbers. So I need two numbers that multiply to 12 and differ by 8. Or sorry, they add to 8. 6 and 2, right? Okay. So 0.625. W minus 6. W minus 2. Okay. What's the method called? Guess and check. W squared minus 2w minus 6w is minus 8w is plus 12. Good. Checked. Okay, what's w? Okay, so now we know these guys, right? From 2 to 6. So what's the width? 4 feet. So the maximum width of the crate is 4 feet. Is there more?
No.
No? Oh, thank God.
Am I recording this?